right, so in this video, we're going to be multiplying binomials by trinomials. Okay, so you've got a binomial here, x plus 3. We're going to multiply it by this trinomial, x squared minus 4x plus 7, okay? We're just going to use the distributive property, okay? We're going to use it multiple times, all right, to help us do this. In the end, we're probably going to have to combine some like terms. You don't always have to do that, but most of the time you're going to, especially with the ones we're dealing with, okay? So what we want to do is we want to take this binomial, we're going to break it into two parts. We've got x, and we're going to distribute that through this trinomial. And then we're going to take this positive 3, and we're going to distribute that as well, okay? So just using the distributive property multiple times. So if it helps you, draw your arrows. So I'm going to multiply x times x squared, x times negative 4x, and x times positive 7, okay? Don't forget your laws of exponents here. We're going to be adding the exponents. X times x squared is x cubed. X times negative 4x is negative 4x squared. And x times 7 is 7x, okay? Use the distributive property a second time. 3 times x squared, 3 times negative 4x, 3 times 7. Draw the arrows if it helps you, keeps you organized, okay? So 3 times x squared is 3x squared. 3 times negative 4x is negative 12x, and 3 times positive 7 is positive 21. Okay, so we got like terms here, the x squares. Those are like terms, we've got to combine those. We've also got like terms with the x's here, 7x and negative 12x. So we have to combine those. There's no other x cubes, there's no other constants, so those are going to be part of my answer here at the bottom. So in standard form, remember we want to write our exponents in descending order, so x cubed comes first. Let's combine these. Negative 4x squared and positive 3x squared is negative 1x squared. 7x and a negative 12x is negative 5x. And then we just bring down the constant 21. Okay, so that's my answer for the first one. All right, so using that example, and you can pause it here and leave this one on the screen, okay? Give this one a try because they're very similar problems, okay? And then come back and check and see how you did. All right, so distributive property again, we're going to distribute the 3x times this trinomial, and then we're going to distribute the 4 by that trinomial, okay? Same policy, and I'm going to try to leave this on the screen so you can see it as we go here. So again, I want to distribute. I'm going to multiply the 3x times all three pieces of that, which gives me 3x cubed minus 6x squared plus 21x, okay? Now we're going to distribute the 4, all right? 4x squared minus 8x plus 28, okay? Just like before, we're going to combine like terms. X squared is there, x is there, all right? Make sure you know how to add those. Remember when you add these, and I didn't say this up here, the exponents don't change when you're combining like terms, okay? Some of you guys were doing that the other day. So we're just going to bring down the 3x cubed, combine our x squares, that gives us negative 2x squared. Combine the x's here, that's 13x, and then bring down the constant 28. So that's my answer for example B. All right, now let's take a look at C. This might look different. You know, we're cubing a binomial, but inevitably we're going to get back to something that looks like this, okay? So first thing, when you raise a binomial to the third power, it just means we're multiplying that binomial times itself with 3 different factors, okay? So what I want to do first is I'm going to do the bi times the bi here. Okay, I'm going to multiply the bi times the bi, okay? And what that gives me, remember we do FOIL method or distribute twice. X times x is x squared. Outside times outside. X times 3 is 3x. Inside times inside is 3x. And last times last is 9. Okay? Now then, I can combine like terms here. Let me bring down this x plus 3 that I haven't used though. Okay? So let's combine like terms. 3x and 3x here is 6x. I'm going to bring down the x plus 3 again, okay? And now you can see I've got a binomial times a trinomial, okay? But this time, and I purposely did this, the trinomial comes first, okay? So up here in the previous examples, the binomial was coming first, and we were distributing these two terms through the trinomial, okay? Well here, and again, I did this purposely just so you see that it works. we're going to distribute these three terms through the binomial, okay? So I've got x squared times this binomial x plus 3. Then I've got 6x times x plus 3. And then I've got 9 times x plus 3, okay? So we're distributing 3 times here. If the trinomial comes first, you can do that and distribute 3 times, all right? So I'm not going to do the arrows here. When I multiply x squared times x plus 3, I get x cubed plus 3x squared. When I distribute here, I get 6x squared plus 18x. And when I distribute the third time, I get 9x plus 27, okay? Couple like terms again, the x squares and the x's. Let's bring down the others. So my final answer is going to be x cubed. Combine these, I get positive 9x squared. Combine these, I get positive 27x. And bring this down for the final part of my answer, okay? So cubing a binomial is a lot like, you know, what we started with here, multiplying a bi times a tri, because when you multiply those first two binomials together, it creates that perfect square trinomial, okay? So that's how you multiply a bi times a tri, and inevitably, you know, this is going to lead to that when we cube a binomial, all right?